Welcome for NA Judy and the viewers who are watching these videos. Our topic is automation generation of biogas through eradication of water hyacinth. Our team ID is Niy-63. Our team members are Ajmal, aamir, Arunkumar, Dhinu, Kiruba and Indrajith. We are from Industrial College of Engineering and Technology, Coimbatore. Water hyacinth. Water hyacinth is an immense water drives which causes a lack of oxygen level for aquatic species. The main concept of this project is cleaning the water bodies from spreading of water hyacinth through automation technique. For past few years, there is a huge water crisis in Tamil Nadu. Nowadays, water hyacinth are removed by manually and it will take more manpower and time. This automation technique used to remove the water hyacinth and store it in a container in order to produce, along with the cow dung, in order to produce a biogas for a period of 10 to 15 days. Next, this is our module design. The sensors and cameras which is interface with the Niy, the proximity sensor which is used to detect the obstacles, and the ultrasonic sensor which is used to detect the distance between the obstacles, and the camera which is used to sense the object and compare with the image which is already stored in the database. This can be done through image processing.
Okay, now I am going to explain the motor driver by the Niy. Niy is a controller which is a combination of real-time module and field program gate array FPGA, which is connected to DC motor and servo motor. DC motor that needs the L293 driver because DC motor operates at 12 voltage, but Niy is not able to supply the 12 voltage, and also DC motor have a disadvantage of backfiring to the controller circuit because it may damage the controller circuit. So for this protection purpose and the prevention purpose, we are using a L293 motor driver. But servo, which has an inbuilt motor driver, so that does not need for the servo motor. Okay, that's next project. Now we are going to explain about the biogas production. Biogas production is a large scale production process, but I am going to explain in simple terms by using two sensors, which is my MQ2 gas sensors and the limit switch, and I have a controller Niy, again the same, and the conveyor motor and solenoid valve. Gas sensor which is placed in a digester which gives the constant value of the concentration of methane in the digester. When the methane concentration is high, the sensors which sends the value to the Niy, and Niy activates the solenoid valve, and solenoid valve stores the methane. And then limit switch which is used in a conveyor motor for the collection of water hyacinth. When it reaches its limit, it activates and sends a signal to the Niy. Then Niy activates the conveyor motor which dumps all the water hyacinth to the digester circuit. Now I am going to explain about the list of components that are using in our project. We have various sensors like proximity, ultrasonic and gas sensor, and motors like DC motor and servo motor, and we are using camera. This is for our primary vision which operates at the 30 voltage, and most of the sensors are operating at 5 voltage. DC motor operating at 12 to 24 voltage, and servo motor operate at 5 voltage. And I am going to explain about the sequence of process happening in our project. First we have camera which is used to sense the image. And it will compare with the database. When it get matched, the match is happen. It tells to the controller. Controller sends the pulse input to the motor driver. Motor driver drives the bot and moves to the near the possible ways. And the proximity sensor which is used to avoid the obstacles in the path that the bot moves on. When the bot reaches its target, the conveyor motor and collects the target like water hyacinth or any bio waste and collect it. After the collection process reaches its limit, the limit switch activates and stops the conveyor. After that, collecting the water hyacinth, the bot moves to the land and get deposited to the ground team. The ground team which collects the water hyacinth, and it is going to happen in the biogas production that I explained in before.
This was the design of our bot, which consists of sensors, motors, drives, image processing controllers and conveyors. Here the pipe is which is placed at the bottom of the bot, which is used to float on the water surface. and there are two conveyors which is placed at the bot. One is placed at the front, which is used to collect the water hyacinth and store it in the container. And the container, when the container is filled, then the bot moves to the land. Then the conveyor which is placed at the bottom at the back side of the bot, which is used to pull the water hyacinth and store it in the container, which is placed in the river bank. The water hyacinth along with cow dung for a period of 10 to 15 days in order to produce the biogas.
Hello all, let me open the VA section which we have done this for this project. Okay, let me move on to the image pattern. Since we replace sensors with boolean value, we have just taken it as a control. Let me run this continuously, and before that we are going to see the block diagram. Okay, this is the overall block diagram. Here we have vision acquisition. This is the session in, that is the vision acquisition, and this is the grab image, and this is the grab image part 2. This is the single color LAN which collects the grayscale or green type images, and this is the create panel. These two are the template and the image. The image, overall image which is going to shown in the output is the image, and the comparable image is the template. Here we have the template file path. The IMAC read accepts all the images, and search pattern, this is the search and pattern making. From this we have the image pattern and matching the threshold values, all the parameters connected with this pattern and matching. Here you see is the unbundle, from which the position, angle, scale and the score bounding box, all the types of the unbundles are connected with the sum, subtract and all the types. Here we use is the here what we seeing is the IMAC overload, and that is the error output for all the values which is going to show in the block diagram. So we have the image which is playing backside in the front panel. Okay, now let's run the project, and we switch over to the block diagram. Okay, let me run this program and make this continuously and getting the highlight execution. Okay, now you can see the values passing through from the image matching and to the unbundle. This is the integer values I32, and you can see the values going by the search image and padding and the grab image. It's sending the true value to this process, and the position is accurate, and it is going to the IMAC bundle. After that all the processes are done in the sequence manner, and if the image pattern matches it, it shows it in a rectangle or square manner, and it shows in the output image. Let me stop this program. Okay, let me switch over to the other VAs. Okay, now we are going to show you the biogas production. Okay, this is the biogas production. What you are seeing is the tab, the two tab I am opening for the front panel and the block diagram. Okay, let me see about the block diagram. Okay, this is the overall block diagram. Let me tell about the execution. Okay, what we are going to see, this is fuzzy logic. I have used fuzzy logic for the overall biogas production. For the methane production, I think so. First of all, the target which is going to do all the things is case study. Okay, the fuzzy system. Fuzzy system, basically the fuzzy system controls the all process in the continuous manner, or the timing control which we have set it in constant 100. This is the basic 100, so that it comes in the 10 seconds or 100 seconds, which we are given in seconds or minutes. Okay, here you are seeing this is the index array. Okay, here we have connected with the various constant values like the index arrays, and this is the NI fuzzy logic controller. Okay, this is the index array. I have connected it to 3 index arrays, which is like the biochemical accelerator, convey, runs, and the temperature. These are all notified in the front panel. Okay, let me switch to the true condition. Okay, here you can see the NI fuzzy logic controller variable with the feedback node. Where is this? Yeah, this is the feedback node, from which I have not set a value of 5, which is set to be equal. It goes to the true value and the whole case structure will run. Okay, this is the fuzzy style. Okay, fuzzy system. This is the fuzzy system, and this is the build array from which we can connect various elements into the sum or any other options. It's like a comparative or any other. Okay, here the values is set to be 0, 1, 2 with the values, and the Ni products like MyRio, it connects to this. Okay, then all the other X-ray graph or index monitoring, temperature monitoring, all these were indicated in the front panel. Okay, let me tell about the execution. Okay, now I'm going to run this project. Okay, I got execution. Okay, the fuzzy system sends true value to this. Yeah, all the time integer variables are connected to test. I have paused this video. Okay, that is the temperature values, error in, error output, and all the systems are basically connected in the correct manner, so that the tap control switch to the index and this I have told you earlier. Okay, let me play this. Okay, you can see this image Ni fuzzy logic controller. Okay, it's giving the 3 values and move to the next adding, and it sends to the Ni fuzzy logic. So if the case it tends to be false, the overall process getting stopped. Okay, let me stop this project. So the next section we dealing with is front panel. Okay, I'm going to show the front panel. This is the front panel VI. Okay, this is the feed into biogas. We have set down the slow, normal, above, superfast. If the feed is getting slower, we can adjust this into normal or superfast. Okay, and this is the block diagram, production process through fuzzy logic control by using the MyRio, and the sensors giving the feedback and the actuators are moving into the working function. Okay, this is the temperature and humidity controller. We can control it through adjustment, and the temperature monitoring gets difference. So shall we run this? Okay, deployment process is getting okay. You can see this. We have adjusted temperature and humidity. We can see the conveyor runs overall improvement, and the values getting different. Now you can see the conveyor and the water spills and the overall. Here we have indicated cold, normal, warm. The temperature process is getting the feedback, and the sludge storage is indicated. Okay, let me stop this. It's not getting stuck. Okay, let's say about it. Okay, let me show the working prototype. Yeah, it is the working prototype of our project. This is the image detection we have created. Yeah, this is the ball. Sorry to say this, we have not ordered plant. Basically we are trying to add the ball image. For getting a clear image, we have used the image detection and the image acquisition through Visa in MyRio. Okay, let me play this. You can see this image is acted through the camera, and it is controlled through the MyRio, and it is sends the feedback to the motor. So if it detects the ball or the plant, it moves to the nearest place, and it's getting the original values through the image detection.